Hey coders, welcome back. So today is day 8 of our daily assessment solutions, right? So I'm solving LeetCode questions from the assessment section. So there is a page, if you don't know, you can go leetcode.com/assessment, and then there we have these three options, right? You can take either OA1, phone interview one, or the on-site interview one. Then there will be random 2 or 3 sets of questions will be generated, and then there will be time limit, and you try to solve it under that time, right? So it kind of simulate real time interview. So this is my day 8 of solving random questions. So today I'm planning to going again an online assessment. So yeah, let's see how many questions are coming, and then I will try to go through my thoughts and understand, read the questions, and I will try to explain what was the prerequisite if I was able to solve, right? So the prerequisite data structure, the algorithm. My primary language is Java, so my solution, yeah, indeed will be in the Java. So yeah, let's start with online assessment. So again, here you can see 2 questions, 1 hour to complete and all, right? So let's start the mock assessment. Excuse me. Right. So, okay, so we have like here 2 questions, right? Let's see the first question. So, given an integer array and an integer value, remove all occurrences of a value in place, right? So, you don't have to use any extra space. Now, the order of elements may be changed, then return the number of elements in the nums which are not equal to var. Okay. And consider the number of elements in num which are not equal to val be k. To get access, you need to do this following thing. Change the array num such that the first k elements of nums contain the elements which are not equals to val, right? The remaining elements of nums are not important as well as the size of nums. We just need to return k. Right, so let me explain you what the question is saying. I can copy paste this thing here. Ah, sorry, I have a cold, so please excuse me for my voice. Yeah. So here it says, the val is 3, so we have to remove all the 3. Technically, we don't have to remove it. We just need to push all these 3 in the right side. So, for example, something like this. Our num becomes something like this: 2, 2, 3, 3, right? And then we can return k is equals to 2. It means till k equals to 2, we have the required elements, right? Like 2, 2. So, just one tip I can say on in place type of questions, like you see here, in place, right? Whenever you have to do something in place, 99% of the time, it is the swapping, right? You have to swap elements here and there, and that is how we're gonna do, right? You will see. So whenever you see this in place now, try to remember swap, because there is no other way you can rearrange those elements, right? So that's the only algorithm you can think of. So what I'm gonna do? Okay, let me get the size of the num dot length, I can say that. Um, then generally, no, this is kind of like if you have solved a quick sort, no, so there we need to find a pivot and then we rearrange the elements, right? All the elements are less than that pivot, we move it to the left side. All the elements which are greater than the pivot, we move it to right side. So this is kind of same. So you can think of, if you solve this problem, I would highly recommend go and try to solve quick sort, especially the pivot part, right? So you can do that. So yeah, so what I'm gonna do now, I will create one index here. It is kind of my like k. So let's say k is equals to 0. Then I will iterate over my nums, right? So something like this. For int, I can say a of nums. So if a equals to val, right? This means we have to swap it, right? So we do not do like this. We generally do something like this. If a is not equals to val, right? This means we have to move all those elements in the left side. So for example, let me show you example here. So here you see 3, 2, 2, 3, right? And val is equals to 3. My k is at the zeroth index, right? And then whenever I see 3, so 3 is not equals to val. No, it is equals to val. So we will continue 2, right? So this 2 needs to be moved to the left side. All those elements which are not equals to val needs to be moved to the left side. So that's the idea, right? So if a is not equals to val, we just need to swap it nums nums with value. Okay, so we have to use the index, not value will not work because on swapping we have to provide that index, right? And then maybe I can do something like this. Um, right. And then if a is not equals to val, this means we have to swap it. Swap what? Swap I with k, right? And then do k plus plus. This means all the elements before the k are at the right place. So that's the idea. And then we can simply return the k. So for example, here is it 3, 2, 2, 3. We take the 3. Oh, it is equals to val. Okay, continue. We go to the 2. Yes, it is not equals to val. So we swap with the very first kth element. The 3 will come here, 2 will swap, right? And then we similarly now we move our k, right? So let me reiterate it here. 3, 2, 2, 3, right? And my k is initially 0. So now we are here at 3 the very first time. My I will iterate from 0 to n minus 1. Sorry. So, okay, so now our value is also 3. So 3 equals to 3. So we are not going inside of this loop. We will continue, right? We go to the 2. Now 2 is not equals to 3, correct? So my k will become 1 and my array, sorry guys, and my array will become something like this 2, 3, 2, 3, right? Something like this. Then I move to this element and my k is 1, right? So this is first swap. Then again we get this 2 right here. Again 2 is not equals to 3. So we swap, right? So it will become 2, 2, 3, 3, and my k becomes 2, right? And then after that we have not seen this any value which is not equals to 3, right? So that's the idea. Let me try running it. Okay, we have because I haven't defined this swap method. A silly mistake. Um, Let me define quickly so I can say public void swap int a maybe I j. Typical swapping algorithm, right? Nothing fancy here. A of I equals to A of j. I still remember my early days. I had problem writing swap method, but I just wanted to say time will teach you. I mean, if you are new, it's just matter of time, right? You just give yourself time and you will be good. So here AI goes to temp and then AI values is preserved so we can override it and then we can compute the AJ, right? Yeah, so for 3223, we are getting the expected result, right? Output is 22. And yeah, let's try submitting it. Okay, so we are able to submit. So the only thing learning I would say whenever you see something like in place, I think of swap algorithm and the complexity here is linear, right? And space complexity is constant because we are not using any space, right? Let's move to the next question. We have some serious cold going on. My nose is okay. So here is another question. So this kind of question I will see the candidate kind of question. This combination sum based questions are very important, right? For interview, I mean, people say it. I don't know. But yeah, let's see. So given a distinct integers candidate and a target integer target, return a list of all unique combinations of candidate where the chosen number sums to the target. You may return the combination in any order, right? And the same number may be chosen the candidate in unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. Okay. Test cases are generated such that the number of unique combinations sum up to the target is less than equals to 150. So if you see the constraint, try to see the constraint very early in the question. It just gives you a hint to narrow down your data structure or algorithm, right? So here is say like 30-40 means kind of like DP or recursive backtracking kind of problem, right? So yeah, you can think of like this also. So basically, you see we have this array 2, 3, 6, 7, and target is 7. Now, if you see there is a famous dynamic programming, that is coin change problem, right? So it's kind of very similar, and these are the standard problem also. So I mean, you should try to solve these kinds of questions. So for example, let's take this example. The only thing, the problematic thing I'm able to think of is how we're gonna handle a duplicate. But let's see. So here now, what is saying, you can choose any number of times and try to make 7. So for example, I can do something like 2, 2, and 3. This is a good combination, right? It will give me 7. Or maybe I can do 7. 7 is there, so I can choose 7. And this is the only combinations, right? So this is the idea. So I will suggest um, to solve dynamic programming problems using recursion, and then after recursive code, defining a recurrence relation and all, try to cache it the sub problems, right? So I generally don't like the TP tables problem, right? I generally like top down approach, which is recursive approach. I mean, pretty comfortable with it, and it always works, and there is no serious time complexity issues, right? But most of the time that is work. But if you're comfortable in whatever, so yeah, how you gonna define this the DP problem? I think the first thing is constraint, right? 30, 40. If you solve so many questions, you will understand. Like 30, 40. I mean, this is kind of DP, right? And the idea is very simple, right? So what we're gonna do now? So last time we did knapsack kind of problem. You can either choose it or not choose it, right? So here it's different since you can choose multiple times. So if so, the idea goes something like this. So let's go to the very first element too. Either, right, I can take it or not take it, right? So if I take it, so it will be 2. If I not take it, nothing, right? Something like this, nothing. Since I have taken it 2 now, I will try to make sure, let's maybe take 2 one more time, right? So if you take it now, you will not increment your pointer. If you not take it, you are going to increment your pointer. So if you know knapsack, this is also kind of similar to that. So let me try writing this method, and then I will try in what I'm doing here. So we have to return answer in list of integer form. So let's quickly define that as a instance variable. So I don't have to pass it everywhere, right? Answer new array list, and I can return the answer. Yeah. So what's the idea? The idea is we have to try making all the combination. So I will generally call my method DFS or helper, or you can call it anything. I generally prefer DFS, and then maybe I can call this A, and maybe this is as a T. So I don't need to type that much, and then I can pass A, and then I start choosing and not choosing element from zeroth index, right? And then maybe I have to also keep track of what are the combination I have chosen, right? So I have to pass a list that gonna keep track of something called path so far. Whatever we number we have chosen or discarded. So it this will keep track of that. So let's add that ESF, right? And maybe also the target sum we also need to pass, because we need to make sure the target sum is going to be 0, right? So if you choose anything, either you can think of it like two way. You take the number and try to make 7, right? Or you can think of, let's take 7 and try to reduce it to 0. Same thing, right? So that's why I'm passing this t. So whenever I choose the number, no, I will reduce that much number from the t, right? So I hope this is clear. Let's write the DFS method first. So public void, I can make it private also, but yeah, let's okay. So we can say start index maybe, right? And then this is the list of integer PSF and my current target. Maybe I can do something like current sum maybe, right? Current required some kind of. Now what's the idea? Idea is we can either choose it or not choose it, right? Same thing with knapsack. So I will go to the A, I will go to the S, I will do the PSF. No, let me write something like so either I can choose it, right? Something like that. Choose it. So what will so if I choose it, that number is going to be added in my PSF, right? So PSF dot add A of S, right? And then I will backtrack. So A. Now since I choose it now, I'm not discarding like I can choose it again because this is what the question says. You can choose as many times as you want. Right. So I can choose it again. That's why I'm not increasing our index. I'm passing the PSF and make current sum minus equals to A of F. This is important, right? Since we have chosen something, then the target will reduce. We need to make sure we are not going out of bounds, right? And then whenever this recursive call happens, done, then we need to make sure we remove the numbers from the PSF. So this is very typical to the backtracking. So PSF dot remove PSF dot size minus and basically remove the very last element that we have added, right? Or not choose. This is the another option. Not choose means we can simply say A S plus one and then PSF since this we're not choosing anything. Now in a recursive based problem, it's sometimes how you're gonna now define your base cases. So for base cases, now try to see whatever values you are changing in your method, right? So you here see my CS is getting changed, my index is getting changed. So this is gonna be used in my base case. So let's first try to write the happy base case, right? Or maybe the unhappy bad base case. So what will be the unhappy? When my this current sum become negative, right, it can become negative, right? Either I can handle it here. I will make sure that my CS minus AS is always greater than equals to 0. You can handle that here also, but let's handle here also, right? If CS is less than 0 means this is bad. I mean, we don't have gonna be have any answer at all, right? And then if S equals to A dot length means we have iterated over all the elements. We do all our permutation, we did all our combinations, right? Now we don't have any option. And if CS equals to 0, this means the exact condition, exact happy case, right? CS, I will CS. So this is the happy case, right? So we have chosen some number from the A that that has been in the PSF that is contains the required subset, right? So I can just add this in my answer, right? Last time also I did this. So pretty standard. We'll add PSF, right? I'm creating a new array list and adding that PSF, right? I'm not don't add PSF reference because whenever we backtrack, this PSF will get empty, right? So always make sure you add something like this, and then you can return it something. For example, so if we have reached out, we have exhausted all our numbers, and if CS is equals to 0, well and good, we can add that into the answer, otherwise return, right? Always it's gonna return, but if it is happening, then also make sure to add that temporary PSF to our answer and then return. Right, so that's the idea. Now, why we have to apply dynamic programming here? Because you see, so sometimes we are choosing some numbers, right? And we are not going beyond S. Sometimes we're choosing S, sometimes we are going S plus 1. So what will happen? There will be some overlapping sub problems. If I try to run it, you will see like TLE. So let me try running it. See first any compile time error. Okay, we don't have a compile time error and we are getting the answer, right? Let me try submitting it. Okay, we are able to submit it also. So yeah, we don't have to cache it. I mean, but I think if we wanted to, I have to trace some value where we might see something like common sub problem, overlapping sub problems, because here you see target is less than equals to 40, right? And what are the things that are getting changed are s plus 1 and this cs, right? So maybe let's try. So current our solution was 2 milliseconds, right? Let's try memorize it and see can we improve this solution or not, right? So what are the things here changing? You see cs changing, means current sum is changing, and my index is changing. So I have to create uh, what we call it, multi-dimensional array, right? I will call it memo. Now what is the dimension of memo is equals to whatever possible values of, right? So I can say something like a dot length plus 1, maybe, just to make sure we are not getting out of bound kind of exception, right? And then the target sum, right? We are always going to reducing the target sum, so I can t plus 1. I think this will be fine. T plus 1. Oops, I don't have to define it here. I have to define it here, right? May, right. And then we can simply come here. Okay, okay, no, 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 sorry, sorry. There will be no dynamic programming here, no, guys, because we're not counting. We have to provide exact replica, exact paths of our things, right? If it was a counting based problem, maybe count how many ways we can make 7. So that's where this memoization might have come. But here, since we need exact answer, it is kind of like a backtracking problem. Right? So I just realized that. So yeah, I don't need to do this. This will be over. This will not help basically. We cannot hash the result for entire sub, right? Because we have to store otherwise the 2, 2, and 3, which doesn't make sense. So yeah, so this kind of problem it comes into the category of knapsack, right? Or this is very typical choosing, not choosing subset kind of problem. So yeah, that's it for this video. I think yeah. So this one we learned the swapping mechanism for in-place stuff, right? And here it is typical backtracking knapsack kind of problem. Yeah, thank you so much for watching. I hope you like it. Let me know if you have any questions. Thank you.